Design and evaluation of two-way interactive video eConsult system, TWIVES, a web-based care and continuity solution enabling secure and private patient-provider connections when mobility is limited or commuting is not an option. Agenda: Introduction, about telemedicine. Research question: Development of TWIVES, development process, technologies utilized. Analysis and discussions, conclusions and recommendations. Introduction: There are critical shortages of healthcare providers in developing countries. WHO 2006. Shortages of healthcare providers in rural and remote communities are usually due to migration to urban centers. Amen and Sullivan, 2001. Expecting excess providers from urban centers to spill over to remote areas has been shown to be ineffective in solving this workforce problem. Strasser et al., 2009. For some patients, traveling to see a healthcare provider could be difficult due to cost and may not even be an option. Lightman et al., 2005. Task shifting. Transfer of primary care roles to community health workers is prevalent in remote settings for efficient use of available human resources. Mitt, Roney, and V., 2008. About telemedicine. The American Telemedicine Association defines telemedicine as the use of medical information exchanged from one site to another via electronic communications to improve patient health status. ATA, 2011. Shreveport, 2011, defines telemedicine as the delivery of healthcare and the exchange of healthcare information across distances. Telemedicine encompasses diverse varieties of services delivered to the patient when distance is an issue. Sipolat and Gages, 2003. Sorrells, Jones et al., 2006, further added that video conferencing, transmission of still images are considered part of telemedicine and telehealth. Modes of telemedicine. Store and forward. Store and forward proves to be very efficient in cases where immediate response is not required. J.C. Lin, 1999. Real-time. Real-time telemedicine requires the presence of both parties at the same time. Kale, 2010. Previous work in telemedicine. Underserved regions. Telemedicine enabled people in rural areas, conflict and crisis areas, the third world, and on airplanes and boats to be cared for and treated by medical facilities located far away. Schmidt, Grendelmeyer et al., 2000. Critical care. An intensive care specialist provided daily consultations to patients in a small private hospital using a two-way audiovisual link. Grundy et al., 1977. Home monitoring. Home monitoring via telephone and television allows doctors to observe the patient's vital signs. Michaels, 1989. Mobile telemedicine. Mobile telemedicine enabled the care provider of cardiac patients to provide remote, non-invasive cardiac diagnostic services using a smartphone gateway. Sparks, Velatus, and McKibben, 2012. Telemedicine in Canada. The cost of referring patients has been estimated to be 10 to 20 times higher than using telemedicine due to traveling and accommodation cost and missed income. Kruger and Niemi, 2012. In Canada, the Ontario Telemedicine Network, OTN, has been very successful at reducing the need for patients to travel to specialists. OTN, 2012, C. However, OTN telemedicine studios are located at health centers and hospitals requiring travel for participants. The enabling technology to facilitate remote patient-provider encounters are now available. Telemedicine in developing countries. Telemedicine has been used for many years to support in developing world. Wooten et al., 2011. Most of the systems often use ordinary email for obtaining specialist advice from other consultants or colleagues in other countries. Bonardot and Wooten, 2010. Results of medical specialist consultations, sampled from several rural clinics located throughout India, indicate that remote expert opinions can improve the speed and accuracy of diagnosis. Emble et al., 2004. Research question. Given the significant cost associated with the setup of telemedicine networks, how feasible is it to develop a web-based solution for community health workers and patients in rural and remote areas, including developing nations, in an environment of low-speed internet connections, limited infrastructure, and relatively small budgets for e-health systems? Development of TWIVES. The creation of TWIVES followed the typical development process of any software, which covers planning, then design, and finally development. Planning. The diagram shows a scenario that was used to capture the essence of TWIVES. On the left side is the patient who is located far away from the health provider required. On the right is the health provider whom the patient needs to consult with. In the middle is the internet, for making the connection between the patient and provider securely and privately. TWIVES was designed to make this happen. Design. The design of TWIVES was streamlined using the UML diagram shown. The user registry is used to control access to the system together with the provider registry. Users are also assigned roles which have assigned permissions. The permissions for the different roles are also editable. Guest user can only browse. Registered user can browse and participate in eConsult. Admin user can browse and participate in eConsult and also can manage the system. Development. The development was done with Drupal framework as shown in the diagram. The data components were identified, followed by module development, menus, user permissions, and then the look and feel of the system. Technologies utilized. For the content management system, Drupal framework was employed, while the media aspect was handled by Red 5 RTMP server. Landing page view. This is the view of the landing page created for TWIVES. As shown in the development process diagram, the look and feel of the system could be changed on the fly without the loss of data, as it is at the topmost layer of the development process. User registration and consultation process. TWIVES was created to be very easy to use, and the following diagram shows the consultation process, from user registration to consult confirmation before the actual consultation session. Video consult view. The video consultation room is as shown in the diagram. The patient and the provider appear side by side, and there's a chat feature at the bottom of the screen that they can use to communicate if needed. The entire consultation session is stored in a secure database which can be searched by providers with the right access level. The consultation information is also exportable to an EMR. Simulations and testing. TWIVES was tested using the following tools and applications. First test was internet connection bandwidth test to establish a baseline for speed. Sloppy was the main bandwidth emulation tool. Charles was used to simulate slow internet speeds. Pingdom was used for page load analysis. And for web browser testing, Chrome, Firefox, Safari, and Internet Explorer were used. Analysis and discussions. Requests done to load page. Pingdom was used to analyze the pages, and what you see are the results. As shown, the file size of the index page is 5.3 kilobytes. Page speed performance. The lowest scored was on avoid bad requests. These were actually found to be from deleted and renamed image files used in the course of the development. Server response codes and load time analysis did not show any critical issues. Size analysis and request analysis were also normal. Web browser test. As shown, The four major web browsers interpreted the page's CSS differently. The site performed well on Chrome, Safari, Firefox, and Internet Explorer. The minor differences were in the menus. Usage share of desktop browsers for July 2012. As shown, Chrome, Internet Explorer, Firefox, and Safari dominate the market. This is to explain why the site was tested for those four browsers only. Page load times at different internet connection speeds. As shown, the system performed well at narrow band speeds. Stable RTMP connection was established at 256 kilobits per second, while RTMFP connection kicked in at 512 kilobits per second. This is significant because according to Akamai, in the report titled The State of the Internet, First Quarter, 2012 Report, Volume 5, Number 1, the lowest mobile internet speed in the world is 322 kilobits per second. This means that TWIVES will perform excellently in Africa, even on mobile internet connections. Test results at various Charles simulated low-speed connections. At 28.8 kilobits per second, it took TWIVES 4,100 milliseconds in total to load the application when the request was placed on the IP address. The request itself took 3,660 milliseconds, and TWIVES responded in 40 milliseconds after that. Latency was at 395 milliseconds, and the actual initialization of the video interface occurred at a relatively slow rate, 1.94 kilobytes per second, and the response speed between the two-way conference links was 6.52 milliseconds. The positive result, though, is that once connection was made, the link remained stable enough for the duration of the transaction. Limitations. TWIVES has not been tested using human subjects. Technical tests were conducted only in simulated low bandwidth environments. Not all identified features were implemented. Conclusions. TWIVES was a proof of concept intended to examine the suitability and feasibility of developing a low-cost video consult system that could be applied in rural communities with limited access to healthcare facilities, health providers, and internet resources. TWIVES POC accomplishes those goals, offering a sleek user interface, a solution appropriate for restricted bandwidth, and a simplified process for registration and consultation management. TWIVES performed well in simulated low bandwidth settings. Further work. Full feasibility and usability testing using WC3 standards in the areas of privacy, internationalization, and web accessibility. Rollout and use in an actual remote setting, and benefit evaluation. Thank you.